exponential growth. And there are many things that grow exponentially. And when something grows exponentially, it grows at a very fast rate typically. Um, and of course, there's a formula that we can use to find out information about new values of something after it's grown over a certain amount of time. And the formula for exponential growth that you're probably going to want to get in your notes is right here. Y equals A times the quantity, 1 plus R raised to the t power. When you raise something to a power, they will grow quickly if it is actually increasing. So you need to know what these variables all stand for. Y stands for the final amount, so the amount of something after its time frame has ended, the time of growth has ended. It could be a bank account. It could be the value of an item. It could be the amount of bacteria. It could be a variety of things that could grow. A stands for the original amount, the amount that you had at the beginning of the time frame. R stands for the rate of growth as a decimal. What percent is it increasing? And it must be written as a decimal. And T stands for the amount of time. How much time or over how long of a period of time was this item allowed to grow? So let's see how we would use this formula for exponential growth in the situation over here. It says we have the original value of a painting is $1,400. So that would be our A. A equals 1,400, the original amount. And the value increases by 9% each year. So I see that percentage. I think of that as a rate. Rate equals 9%, and as a decimal, I have to move my decimal point 2 places to the left, so that would be 0.09 as a decimal. Write an exponential growth function, so there's a little bit of a typo there. Write an exponential growth function to model this situation, and then find the value of the painting in 25 years. So 25 years, I see that as a time. The time is 25 years. Every year, its value increases by a rate of 9%, and I want to find the final amount. So I want to find out what y is. Y equals. So my original amount is 1,400. Okay, so original is $1,400. And we need to multiply that by 1 plus the rate of increase, which is 9%. Whoops. I'm trying to do the whole color code thing here. I might have to abandon that here in a little bit once we start doing some of this math. And that is increasing for 25 years. So it increases by that amount for 25 years. So let's see what its value is going to be at the end of the 25 years. 1 plus 9%, or 1 plus 0.09, 900ths raised to the 25th power. So 1 in 900ths raised to the 25th power is a pretty large number. And I'm going to times that. It's not really large, but it's a long decimal. I'm going to times that by 1,400. And then I will round it at the end. So I find out that at the end of the 25 years, the value of the painting is $12,072, and I don't remember the cents. 31 cents is what that's going to round to. 31 cents. So pretty good investment for his money in order for that photo to make just over $10,000 in 25 years. Okay, there's some other types of exponential growth too. When you're talking about the value of your money when you put it in the bank, that can grow exponentially as well. And of course, there's a different formula for that because there's a few more variables involved. A is going to stand for the new amount, just like it did in the last formula, except we used Y. So A is your new balance after a certain number of years. P is equal to the principal, which is the amount that you started with. So like in the last one, we had A, the lowercase a, standing for original amount. P stands for principal. That's the technical word for um, an investment, an amount at the beginning of a bank investment, or even if you take out a loan and you borrow money, that's called a principal as well. R again stands for the rate, which has to be as a decimal. N equals the number of times that the interest is compounded in a year. When you invest your money or when you borrow money, there's this thing that's called interest. If you're investing, interest is something that your money gains and your money grows as the longer that you keep it in the bank. Um, so when they compound the interest, that means they calculate it and they put it in with the rest of your money. That way, your money and your interest has a chance to gain interest. So we want to know how many times they do that every year, and we have to consider that when we are using the formula. And T stands for the number of years that your money is staying in the bank. So I will try to do the color coding here. So $1,000 is invested. So that tells me my principal. The money that I start with is $1,000. It's invested at a rate of 3%, and it's compounded quarterly. So that's the N. That's the number of times every year that it's compounded. And if it's compounded quarterly, there's 4 quarters in a year, so that means it's compounded 4 times a year. They calculate interest, put it into your account 4 times every year. And we want to write a compound interest function to model the situation and find the balance, the new balance, after 5 years. So our time is 5 years. Okay, so we need to take that information and put it into the appropriate spot in the formula. And I'm just going to use black here because it's going to be hard to switch back and forth. So the principal is $1,000, and I'm just plugging the numbers in as I see them pop up in this formula. Then I have a 1 plus my rate as a decimal should be 0.03. The number of times I compound is 4. And my exponent takes the number of times that I compound and times it by the number of years. So 4 times 5. If your money is in the bank for 5 years and it's compounded 4 times each year, then it's compounded 20 times. So really that exponent is the number of total times that your money gets compounded. I'm going to find out what 300ths divided by 4 is. It is 75 10,000ths. And I'm going to add 1 to that because that's what all the stuff inside the parentheses does. So 1 and 75 thousandths raised to the 20th power. Then I'm going to take that amount that's on my calculator right now and raise it to the 20th power. And that amount is going to get times by 1,000. To find out that after 5 years, I have 1,000, I think it was $161, and there was some change involved. It's going to round to about 18 cents. So after 5 years, your money makes $161.18. You might say, well, that's not very much. And you're right, it isn't, but it's more than what you would have made if you left your money sitting somewhere at home or if you had spent it. 3% is a pretty high rate. I'm not sure what the going rate is right now for a savings account, but 3% does seem pretty high. But you can see that your money can grow. In the first example, the painting's value increased. Usually the value of a car will decrease. That's the exponential decay, which we'll talk about in the next video. Although after a certain amount of time, if the car is old enough and in good enough shape, it becomes an antique, and then its value starts to increase, which is kind of a weird scenario there. But the next video, we'll talk about exponential decay.